Let us summarize the algorithm of honest method. Suppose you are asked to find out root of f of x equals 0. Then you will look for values x1 and x2 such that f of x1 and f of x2 takes opposite signs. You will identify the interval inside which root of f of x will lie. Suppose x1 equals alpha and x2 equals alpha plus 1 is the interval inside which root of f of x will lie, and alpha is the lower bound of the interval. Then we will select alpha as the integral part of root of f of x. Suppose d1, d2, d3 etc. are the digits occurring in the decimal part of root of f of x. Then we have root of f of x may be written as alpha point d1, d2, d3 etc. Now our intention is to find out d1, d2, d3 etc. For that, we will diminish the root alpha point d1, d2, d3 by alpha, so that we will get the root 0.d1, d2, d3. When you diminish root of f of x equals 0 by alpha using synthetic division method, you will get a new transformed equation g1 of x whose root will be of the form 0.d1, d2, d3 etc. If you multiply this root using 10, new root will be d1 point d2 d3 etc. But in order to get the equation whose root is d1 point d2 d3 etc., we have to multiply g1 of x using powers of 10. Then we arrive at the new equation f1 of x. We find out values between which root of f1 of x will lie using rule of Descartes. We will look for x1 and x2 values so that f1 of x1 and f1 of x2 will take opposite signs. We identify the interval in which root of f1 of x will lie, and the lower bound of this interval will become d1. Thus we have found d1. Our next step will be to find out d2. In order to find d2, we will diminish the root of f1 by d1 so that the new root will be of the format 0.d2, d3 etc. That is, you will adopt synthetic division method to diminish the root of f1 by d1, and the new transformed equation will be g2, whose root will be 0.d2, d3 etc. When you multiply this root by 10, you will get the root d2.d3, d4 etc. We wish to multiply this root using 10 so that we can bring d2 as the integral part. In order to obtain the equation f2 whose root will be d2.d3, d4 etc., you have to multiply g2 using powers of 10. Thus you arrive at equation f2 whose root will be d2.d3, d4 etc. Since you have obtained the equation f2, now you will use the rule of Descartes in order to find out values between which root of f2 will lie. You will look up for x1 and x2 values such that f2 of x1 and f2 of x2 will take opposite signs. Once you have identified the interval in which root of f2 of x will lie, the lower bound of the interval will become d2. If you are asked to find out till 3 digits after decimal point, then you will have to find out d3 as well. To find out d3, we will diminish the root of f2 of x by d2 so that you will get the new root in the format 0.d3, d4 etc. When you diminish f2 of x by d2 using synthetic division method, you will arrive at the new transformed equation g3 of x whose root will be 0.d3, d4 etc. When you multiply g3 of x using powers of 10, you will get the new equation f3 of x whose root will be of the format d3.d4, d5 etc. We are multiplying the root 0.d3, d4 etc. using 10 so that d3 can be brought as the integral part. Once you have found the equation f3 of x whose root will be d3.d4, d5 etc., you can use rule of Descartes to find out values x1 and x2 between which root of f3 of x will lie. The lower bound of the interval will become the integral part d3. With the help of an example, let us understand the fact that multiplying root by 10 is equivalent to multiplying the equation using powers of 10. Suppose we have an equation g1 of x equals x minus 1 the whole square, which equals x square minus 2x plus 1, and we have root of g1 of x is x equals 1. If you multiply x equals 1 using 10, you will get the new root x equals 10. We have x minus 10 the whole square will be the equation whose root is x equals 10. That is, we have obtained the new equation f1 of x whose root is x equals 10. We have f1 of x will be x minus 10 the whole square, which is x square minus 20x plus 100. But you could also arrive at f1 of x by multiplying g1 of x using powers of 10. If you multiply x square using 10 raised to 0, 2x using 10 raised to 1 and 1 using 10 square, you will get 10 raised to 0 times x square minus 10 times 2x plus 10 square times 1 equals f1 of x. This example illustrates the fact that if alpha is the root of g1 of x and you wish to find out f1 of x whose root is 10 times alpha, it's enough to multiply g1 of x using powers of 10. Let us quickly recap this problem to understand the algorithm better. When you are asked to find out root of x cube minus 3x plus 1 equals 0 and you identified that between 1 and 2 root of this equation will lie, you take the lower bound of the interval 1, 2 as the integral part. Thus you have the root as 1 point d1, d2, d3 etc. You wish to find out d1, d2, d3. You are diminishing the root of f of x by integral part 1 using synthetic division method. Thus you arrive at transformed equation g1 of x whose root will be of the format 0.d1, d2 etc. Once you have found g1 of x, you will find out between which values root of g1 of x will lie. You identify that between 0 and 1 root of g1 of x will lie and thus we have 0 becomes the integral part of root of g1 of x. When you multiply roots of g1 of x using 10, which is equivalent to multiplying the equation g1 of x using powers of 10, you will get the new equation f1 of x with the root d1 point d2 d3 etc. We have done this to bring d1 as the integral part. Now we will identify values between which roots of f1 of x will lie. We have identified between 5 and 6 root of f1 of x will lie. The lower bound 5 will be taken as the integral part, that is integral part d1 which is the integral part of root of f1 of x becomes d1 equals 5. Thus root of f1 equals 5.d2 d3 etc. If we wish to find out d2, we will diminish the root of f1 of x by 5 using synthetic division method. We arrive at new transformed equation g2 of x whose root will be of the form 0.d2 d3 etc. When you multiply g2 of x using powers of 10, you will arrive at the new equation f2 of x. Again using rule of Descartes, you will find out between which values root of f2 of x will lie. You see that in the interval 3, 4, root of f2 of x will lie and the lower bound 3 becomes the integral part of root of f2 of x. Since root of f2 of x was of the format d2 point d3 d4 etc., now we have obtained d2 equals 3. If you wish to find out d3, then you will have to diminish the root of f2 of x by 3 so that you will get the new equation g3 of x whose root will be of the format 0.d3 d4 etc. You will perform synthetic division method on the coefficients of f2 of x to obtain g3 of x. Now you will multiply g3 of x using powers of 10 to arrive at f3 of x. Roots of f3 of x can be found using rule of Descartes, that is you will find out x1 and x2 values for which f3 of x1 and f3 of x2 will take opposite signs. Once you find the interval inside which root of f3 of x will lie, lower bound becomes the integral part d3. We have the required root for the equation f of x equals x cube minus 3x plus 1 is given by 1.532. Having found d1 equals 5, d2 equals 3 and d3 equals 2 using Horner's algorithm.